Hello everyone. Today I'm starting a new series whereby I will do lead code questions, but the idea is not to kind of do this lead code question to an extent that you might have worked a lot on lead code questions, but we like to kind of do this question with the point of view that when you go for programming interview, what are the things that you should keep in mind? So it is not really about just about teaching you about the algorithms. It is about how you should approach it and what are the uh, things that you should keep in mind and how clean you should write your code. So we'll try to learn this from this series of videos, and I'll try to put out videos which is very relevant and for which you will learn little more than just doing an algorithmic questions. So this particular series is not only about algorithms. There are a lot of videos who have done a pretty good job on algorithms, but this series is about how clean, how we should write this code, how clean it should be, and how we should approach these problems. So nowadays, the kind of programming skills needed for people with mid-level of experiences is going much higher because people are not only expecting you to write a clean code. They want to write you to write a code which is very readable. They want you to write a code as if you're writing it as a part of a library that you will offer. So the that's how we'll approach this. So I picked up a problem which is very simple. Almost everybody knows how to do this, but I'll try to walk through it and show you how you should write your code. For more or less, I'll write everything in Java, and you can basically follow along as I write. So this problem is about a binary search, and it just says that given an integer, like for example this. So given an array of integers, we have to find out if there's a target that exists or not. So that's the first target. So now I'll first write the code as if anybody else is writing it, and but then we'll go and modify the code and we'll try to make it more conform to a Java programming language, or if people are using their different language, they can use a different set of libraries. Uh, so first thing we have to do is checking the input. So if you say now the first thing we'll do is we'll make some boundary checks. We'll say if num is equal to null or nums dot length is equal to 0. So you are kind of validating the input. You just return -1. So one of the things that you always want to do is put the curly brackets, and it is because this is one of the coding practices that is in most of the companies, and there are lint check done on this. So people don't write, at least in Java, they you don't write code without curly brackets. So you need to write this. So this is the first check you will do. You will make sure that if nums is equal to null or if nums dot length is equal to 0, you return -1. And there's one more thing you need to do here. When you're building a library to write this code, you need to build some clever optimization. So one simple optimization we'll build is we'll say that if target is less than nums 0, it means target is even before the start of the first number, or if target is greater than nums dot length -1. So this is the last number of this particular array. So if target is outside this particular boundary, then you would like to kind of make sure that you just return -1. So you don't even have to go on any optimization. You can just return -1 and that should do. Uh, so we'll just do return -1. Now, well, now we have to define the thing. So first thing I will do is I'll define the left range, starting variable left. So this array, the left here is -1 and the right is 12. Now you've seen I've named it as left and right. I've not named it as L and R. Usually, or I have not named it as something else, and that is simply because to make this code more readable. Uh, And that's how you should approach your programming interviews also. You have to write code which is not only correct, but it is easy to read, easy to understand, and easy to debug. So now we've defined left and right, and we will just define mid, and we'll set it to -1 right for now. So what we as you know, in binary search, all we do is we check the left, we check the right, uh, we find a mid element. If the mid element is equal to the target, then we return the index. If it is not equal to the target, if it is less than the mid element, then we move to the left, otherwise we move to the right. So that's a very straightforward logic. Almost everybody who's doing programming interviews or preparing for it will know this particular thing. So what we'll do is we'll calculate the mid, and we'll say mid is equal to left plus right minus left by 2. So it will go to the left element, and then it'll find out what's the distance between right and left, and it will walk half the distance of that. And what we do here is we check if nums dot mid is equal to the target. So we are looking for this particular target. If that's the case, and again use curly brackets, then we return the index of it. So we return mid. Else if nums dot mid is greater than target, then we know that the target value is sitting on the right hand side of it, because okay, so in this case the mid value is basically greater than the target, so target is sitting on the left hand side. So what we do is we make the right side, the right equal to mid minus 1. So we basically or else we make left is equal to mid plus 1. So that's how we do it, and we just check if left is equal to, so there's an equal to sign. We would like to run it if left and right are both equal, and if they're not equal, then that's fine, then it will get out of that. So here after getting out, we'll check if left is greater than right. So did it get out? Because when it, so in this case it kind of jumped out of this particular loop only if left is equal to the right, otherwise it would have found mid. So we are sure that left is definitely greater than the right. It means it did not find it, and we return -1 here. So let's try to run the code and see if that works. Okay, that will works. And let's try to submit it and see if that works. So this one works, and it says it's 0% faster than 100% of the Java Online submission. Memory, it says 40.1 megabyte, less than 40% of the Java Online submission binary search. So one thing you have to keep in mind is generally I prefer you should check this Java class called objects. So objects has a lot of predefined methods, and I will tell you why. These things are very so instead of writing the whole code for this, you can say require non-null, and you can say nums. So generally for int we cannot pass null anyway, but for nums we can pass null, so you should check for that. And for that you don't need this particular you have to check if it requires non-null, if they pass a null value. In this case they say return -1, but generally the way you write your program, and this is something you can talk to the interviewer, that always you can throw this throws exception, and you can define what type of exception you're going to throw. So if you find out null, you're going to throw some exception. If you find num equal to length, then you're going to throw some exception, because if you look at this program, it's not very clear why you got -1. So did you pass something bad because of which you got -1, or did this target was really outside this range, that's why you got -1, or you could not find it and that's why you got -1? Why you got -1, you do not know that. So that's the reason why we should generally in programming interviews change the signature to have some exception to bring in more clarity on why something failed. either you can put some logging statement within this, but generally the client that is running this particular calling this search method will not know about the logging. So the client needs, the way to communicate to the client is either you pass different codes. You can say -1 for if I don't find it, -2 for if I'm going to find something, if you pass me incorrect values, and -3 if it sits outside this particular range or something like that. So you have to get that signature correct, or you can say that I will throw different exceptions based on different type of input. So for example, I will tell you how we do that. We can say that while if nums equal to null, then we throw, or instead of doing this, we can take this out. We can say throw new exception, and you can create your own exception, but there are already created invalid input. Throw exception input. So you can and I say this because in one of the programming interviews I was asked this question, that the program itself was very simple, but they wanted me to write a program as if this is part of a library, and my code should really cover all the cases, all the corner cases. Usually in lead code that's not like what is expected, but in programming interviews that definitely expected. So thank you for joining this particular video, and I'm going to provide more videos and more insights into how to approach tougher problems. Nowadays the problem set has become more and more tough, but they have not become tough because algorithm has become tough. They've become tough because uh, the expectation on the programmer is much higher, that the programmer would think through a lot of uh, corner cases and would be more as an expert programmer. So thank you for listening to this particular series. If you have any feedback, please provide me. This is my first video, so subsequent videos will become better and better, and it will be more clearer to you. Thank you for that.